Hello and welcome back to the Pendle Suite. Our next speaker is here in real life. It's Christoph, here to talk about WebRTC test platforms. Let's give him a very, very large ComCon welcome.
Thanks.
Christoph.
Yeah, thanks a lot. Thanks for being here. I know that the competition is actually very strong here, so I appreciate you being here. And I definitely rewatched the other talk as well, so I can't blame anyone for not being here. So my name is Christoph. I'm a freelancer. I build multimedia applications for the web. And I'm not sure about you. Maybe you used a few media APIs in the browser as well. And sometimes they actually don't do what they are supposed to do. And there are some little tiny browser inconsistencies. And the web platform tests are a project which tries to deal with that. And that's the logo. Yeah, it looks very convoluted, and the project is actually very, very big. But I'm here to convince you that it's not intimidating at all, and it's very easy to add a test to it. And yeah, I really want to convince you that whenever you run into an inconsistency, then just add a little test for it, and then it will hopefully go away and will never come back. So when we talk about web platform tests, we obviously have to somehow define what the web platform is. And in terms of the web platform test project, that's actually a combination of the browsers and the standards. And in particular, the standards as they are defined by the W3C and the What Working Group, and the browsers like Chrome, Edge, Firefox, and Safari. And yeah, obviously there's, at least in my opinion, there's a bit of a gray area. Like the web platform is, in my opinion, it's more like there are implementations of the standards outside of the browser, and there are NPM packages implementing the standards, and so on and so forth. But for the web platform tests, it's actually only testing the browsers. But yeah, that's a huge chunk of the platform already, so it's definitely a good thing. And yeah, a brief warning: I'm not the inventor of the web platform tests project. It was, I think it goes back to 2006, so way before I got interested in the topic. And I'm also not a regular contributor to it. I'm just infrequently contributing and lurking from the sideline. I'm not affiliated with any company involved in it, so I'm just yeah, a web developer which is relying on the web platform to be stable, and that's why I'm so curious about it. So yeah, keep that in mind. I'm not. It's not an official content that you get from me. So as I said, the web platform test project is very, very big. It's these are just the numbers I got a few days ago. Like there are over 55,000 commits and 1,000 open PRs and even more issues. And all of that has been done by 1,500 contributors. And like, if you imagine you have to maintain a project and there are 1,000 open PRs, I guess this is quite terrifying to think about something like this. But yeah, the web platform test is a very old project, but I think if it would have been done today, people would just call it a monorepo, because it's actually split by specification. Like each specification that's tested has its own little subfolder, and different people are responsible for different specifications. So it's actually more or less a monorepo consisting of a lot of different projects. And that's also the reason why it's, I won't say it's easy, but it's quite manageable to have so many open PRs, because they all touch just files within a certain subfolder, so they rarely conflict with each other. And these are the, just looked at the top contributors and then picked their affiliation, and these are just the usual suspects, the big browser vendors, and Adobe also has a huge web stack, and then W3C, of course, and Igalia and Bocoup. In case you don't know, these are two consultancies which also contribute to WebKit, for example, and yeah, yeah, that's also why they show up in that list. And yeah, I think I already said it, but just to point it out again, the official reason for the project is that it should increase the maintainability and stability of stability, that's what I wanted to say, stability of the browsers, and to make sure they are all tested against the same test suite. And obviously, I think one of the reasons for the browser vendors to collaborate on that is that they can save costs by doing so, that they don't have to maintain a test suite for their own browser, like they can use one with the others. And a nice side effect of this is that these tests may outlive the browser engines. Like, I don't know this for sure, but I imagine that Internet Explorer and Edge were somehow tested as well, but these tests were just discontinued as well when the browser was discontinued. So this test suite actually allows tests to live longer than the browsers. And it also allows new browser engines to come up, which is obviously a tremendous task if you want to start a new browser engine, but you could use these tests to make sure you are compatible with the existing ones. And if you want to take a look at the current results, there's a page called WPT FYI, which just lists the latest test results. It's updated by daily task, I think. And I picked these numbers this morning. They are different by now already. But there are around 1.8 million tests, and around 1.7 million tests are passing. And this looks very impressive, but it also means that there are still 100,000 things which are not quite compatible, or not quite the same in each browser. And it could be even 400,000 things, because these numbers don't tell us if the passing tests are actually the same passing tests in every browser, or if we, just by bad luck, have 100,000 different tests in each browser which fail, so then it would be 400,000. And it's very hard to compare these numbers. Like, there are optional things, optional features, and if an optional feature isn't implemented, then this doesn't count as a failure. But if it's implemented and it fails in a certain sub-feature, that's a failure. So it's very, very difficult to compare these numbers. But anyway, people do it. And there's a project called Interop, which is a yearly project. And it's actually measured somehow with the web platform tests percentage, like coverage percentage. And it's a certain subset of APIs which get picked every year. I think it's the third time they do it, which all the browser vendors commit to improve during the year. Like, they commit to improve all the time, but they put special focus on these APIs. And I think for us here in the room, the two most interesting ones are the off-screen canvas and web codecs, which are meant to be improved during this year. And this is actually the list that they choose is largely taken from a survey that happens every year in December, November. So if you somehow come across the survey in November and December asking you for your favorite browser APIs, make sure you tick all the boxes on the media-related ones. That would be very nice of you. And the other page that is maintained by the project is WPT Live, and this allows you to run tests live in the browser. Like, you can just open the page and run the tests. And this is very helpful if you want to run tests in a browser which is not on this list of the 4. For example, Samsung Internet or some other browser. Then you can just open the page and run the tests. Obviously, this only works for the tests that don't require any special permissions. Like, some tests need to disable the autoplay policy or disable a few security rules, and this doesn't work with the unmodified browser. But it's actually quite nice if you get a bug report from someone saying this page doesn't work in Chrome 102 or something, and you have no idea what was the set of supported features back then, because it's, I think, already 10 versions, 12 versions ago. So yeah, you can just ask the user to open the page in WPT Live and go to the API and check, and then tell you what's actually working and what doesn't. And finally, WPT is the command line to run things locally. Like, this is what you would use if you want to run a test locally. You can just do whatever you would expect from a modern dev CLI. You can run the tests. If you just specify the browser, it will run the tests in that browser. If you specify the API, it will run only the test for the API. And if you specify the full file path, it will just run the test for that file. It will also do the linting for it if you want to. Like there are certain rules which are enforced, and you can check if they are valid or not. And then, yeah, all the other, it does a lot of other things. And if you want to find out, then you can just run WPT help, and it will tell you. And the basic architecture of these tests is not very very unique these days. Like it has a WebSocket and HTTP server that's written in Python, and it's not an off-the-shelf server because it needs to send broken things to make sure the browser behaves correctly when it gets those, and then it does the automation via WebDriver, which is also a web standard, and then finally it runs these tests in the browser, and all these different parts communicate with each other, and there's a bigger, more convoluted diagram which you can see by following the link at the bottom, but it's basically yeah, just that. And this looks very familiar if you know about Playwright or Puppeteer, and that's actually because it's completely the same thing. Like it's, but again, I think the reason why they have a custom implementation is because first, WebDriver is a web standard, and they probably want to dog food their own tests by using their own protocol, and second, because it was like predating all the yeah, definitely Puppeteer and also yeah, Playwright as well. And there's a new protocol coming up. I don't know if you heard of it, called WebDriver BiDi, which is going to solve the issues, or is meant to solve the issues with WebDriver, and I guess sooner or later Playwright will implement that too, and then maybe this all becomes the same again at some point. And these are the different types of tests that you can actually write. There are a lot of tests, but in the end, you mostly write only one of them, which is the test harness JS test, and that's basically like any other JavaScript test that you usually write. It's a different syntax, but it's the same as Jest, Mocha, Jasmine tests that you probably came across already. And then there are IDL tests, which test the interface. IDL is Interface Definition Language, if I recall correctly, and it's the way the APIs are specified in the standard. Like it's a yeah, a certain kind of language, looks a bit like TypeScript, but isn't TypeScript, and also has different types which are not available in JavaScript. Like you get doubles and longs and all of that, and it has certain conversion rules, and these can be checked automatically with these tests. Then ref tests is something which you would normally call a snapshot test maybe these days, or visual regression test. And it's just rendering something on screen and then comparing the result. And yeah, if it matches, it's a passing test, and if not, it's a failure. Visual tests are the very same thing, but they are so complicated that they cannot be verified by a machine. So they also do something on screen, but it's a tiny bit different every time. So the human has to verify it. And manual tests obviously also need to be run by a human, and that's why they are discouraged and should not be used. Like if you have to write one of those, then it's a last resort, and yeah, it's better not to do it. And finally, crash tests do just what the name says. They try to crash the browser, and if it doesn't happen, then it's passing. If not, then it's a failure. And finally, the WD spec, this is for WebDriver. Like there are Python tests which test WebDriver, which is then used to run the other tests. So yeah, that's why they are written in Python, because they have to run outside of the browser. But normally just test harness JS tests, and that's fine. And yeah, all the things are automated. I just wanted to quickly mention this, because if you run into any issues, it's probably because some of the automation kicks in. File names have to have a certain ending to get picked up. If you want to run them on the worker, you have to give it a worker ending. If you want to run it on the main thread, it's a different ending as well. And yeah, so there's a convention for almost anything. And then there are also meta tags and files that you can meta files that you can use to tag certain people. For instance, if you are interested in the WebRTC spec, you can add your own GitHub handle to that meta YAML file, and then you get notified whenever someone submits a PR to change the tests. Okay, so finally, let's look at the syntax. And it all boils down to a simple assertion. Like, this is what you can do. Like, you can check that something is equal to something else, and this allows you to do everything else on top of it. Like you can build it on your own, but there are already built-in helpers like assert not equals, for example, assert true, assert that something has a property of a certain type, or that something is available in an array, or so on and so forth. But yeah, just the usual functions that you would expect from a test framework. And to put it in a test, you just wrap it in the test with the test function, and then you have a test. But you can also do this with a promise, of course. If something is not synchronous, just wait for the promise, and then you chain the assertion afterwards. And if it's asynchronous but not a promise, then you can do it yourself by using this T helper, and then do T step to do an assertion. And if you are done with your assertions, you could just call T done, and yeah, it's doing the same thing in the end. And then you also have setup and cleanup if you want to do something up front, and if you want to do something after the tests. The only little specialty here is that it's having a global setup, but it's only having a scoped cleanup, but I guess that's fine. And then there are also timers. I just wanted to mention it for sake of completeness. But yeah, as with any other framework to run tests, if you don't have to mess with time, I would recommend to don't do it. So yeah, just don't do it. But having said all that, the WebAudio API, which is the API I'm most interested in, doesn't use it. Like, they have their own framework, and this is also like any other obscurity. It's for historic reasons, because the tests were available in the Chromium project before, and then they got ported to the web platform test. They use something called audit.js, which is like test.js, but uses a different syntax. But nowadays, they at least removed all the assertions from audit.js so that it's just a syntactic layer on top of it, like it's using test.harness as well. So you probably all know this. If you want to start, you have to clone the repo. It's very big. That's why I put it on the slide. Like, if you are on a poor connection, you can do something while it's downloading. It's very big. And then on top of that, you probably also need to download the Chrome and the Gecko drivers to run the tests. And then the official documentation says you have to install Python, and you also have to modify your host config. But I don't doubt that this is true, but if you run only a few specific tests for specific APIs, you may not need it. Like, Python is already installed on macOS, for example, and if you don't run tests which need a redirect, you don't have to do it. And since you normally only work on a tiny subset of the repository, then I would recommend to just try it first, and if it's necessary, then install Python, and if it's still failing, then do the host config modification. But if you don't have to, just don't do it. So let's look at the tiny bug which I got told about a few weeks ago, I think. Like, I'm maintaining a project called Standardized Audio Context, which tries to be a layer on top of the WebAudio API to make sure it behaves similar in each browser. And the project, I think, is, I don't know, it's a few years old already, but there are still tiny things which I have no clue about. Like, someone told me that the default value is actually wrong, and like, if you set it to 0.5, as in this example, and then you read it back again, it's still 1. And the thing which made me extremely suspicious about this is that it's actually working in Safari, but not in Firefox and Chrome. And this, like, for historic reasons, the WebAudio API in Safari was actually very poor, but yeah, so I was wondering, why is that working in Safari and not in the others? And I don't know it for sure, but I think it's, again, for historic reasons, because at the first version of the WebAudio API had no constructor, and the only way to create a gain node was by using the function, which didn't take any parameters. So the default value was always 1. You had no chance to change it. And I guess that's why they just forgot to implement it. And Safari implemented it later. So yeah, that's why they probably implemented it. Anyway, the test for it is very simple. It's just creating an offline audio context in this case because that's using less resources, and then sets the default value, reads it back again to see if it's working or not. And I chose to write a web platform test for it because it's failing in Safari. No, it's not failing in Safari, but it's failing in Firefox and in Chrome and in Edge, respectively. So I could have filed a bug for all of these browsers, but I could also write just one platform test, and then it's supposed to trigger errors in the browser test as well. So hopefully this saves me some time to just submit one pull request instead of 2 bug reports. So as I said, the Web Audio API uses audit.js, so it's the very same thing, just a different syntax, because why not? And then another thing which I wanted to tell you about is like an interesting edge case of an API, which is very, very simple. It's just a Boolean property that you can set on a media element called preserves pitch, and it either preserves the pitch or it doesn't. And that means if you can change the playback rate, but the frequency content should be the same, or you change the playback rate and you get the usual Mickey Mouse effect. And there's actually, the API is just a Boolean property, but the test is very complicated. It's playing a sine wave at a fixed frequency, pre-recorded one, like from a file, and then does that with an audio element, then grabs the media stream, pipes it into the Web Audio API, uses an analyzer node to read the frequency spectrum, then very roughly picks the loudest frequency, and then compares that with the frequency it had before. And this works to verify that it's actually not changing the frequency, but it's, imagine if you would be a test-driven developer implementing a new browser. You actually have to do nothing. Like, if you wouldn't do anything, the test would pass as well, like, because it doesn't check if the tempo changes. The original file is just a sine wave, so it's periodic, and you have no chance to determine if the playback rate is actually changed or not. So yeah, I think it's a very nice test because it shows that you can use other APIs to test another one, but it also shows the limitations of the project. But yeah, it's maybe something someone here should fix. And if you fix it, you actually become a contributor to the browsers themselves. I think I already said it, that the browsers sync the tests into their own code base, and they contribute the tests back into the web platform test project. So if you happen to write a web platform test, your code also ends up in the browser code base. So writing a bit of JavaScript is, at least for me, it's the easiest way to get into the browser code bases. And another thing that is hopefully making the project bigger and bigger over time is that a lot of APIs require web platform tests now to reach candidate recommendation. And yeah, the Web Audio API has, for example, that policy. The quote is from the Web Audio API, and SVG working group has the same. And yeah, I think a lot of others as well, but I was just too lazy to search for other links. But it's becoming like the new norm. And I personally often use the web platform tests to see how things should actually work, because reading the spec is sometimes complicated and doesn't really tell you the whole story. At least that's my experience. And then you can look at the web platform tests. For example, a few weeks ago, I was wondering what's actually happening if I set the ICE candidate pool size on a RTC peer connection. And it's doing something, but I was wondering, is it supposed to fire an error? Do I have to attach handlers to it? What happens if it fires? And so on and so forth. And luckily, it does nothing. Like it's doing something internally, but it's supposed to not show this to the outside. So you don't have to listen to errors as well. And you can use it to discover some neat tricks for your own tests. Like the web platform test, as I said, it has to run some tests in a privileged mode, where it, for example, disables the autoplay policy, yeah, and some other security rules, like which normally prevent you from fetching the configuration of the browsers actually sets a lot of flags which are barely documented elsewhere, and you can kind of guess from there what they are doing and try to figure out yourself if you can use them for your own tests or not. And finally, as I said in the beginning, web platform tests are actually useful outside of the browser, and if you do something which implements a standard somehow, you can actually use web platform tests as well. Like, I just found these two examples. There's an exporter or something in the Node.js repo which kind of tests against the web platform test, and also JS DOM, which is a JavaScript implementation of the DOM, does a similar thing. And I wanted to mention at least that there's another project called Kite for WebRTC, and I didn't really know at the beginning why are there two projects doing the same thing, but as I found out, Kite is more for doing tests between browsers. Like, web platform tests have this limitation that they test a feature in a certain browser at a time, and obviously with WebRTC that doesn't really cover the whole picture, and you also want to know if browsers can talk to each other, and that's what Kite is doing. And maybe some of you know that on Can I Use or MDN you also see compatibility table, and this is actually something totally different. It's not using web platform tests. It's, as far as I know, manually compiled JSON documents which they maintain, which is a very big task. And yeah, I'm not sure why these projects are not generating the data automatically. And the very last thing, there's also something for ECMAScript, which is not, it's also part of the web platform, I would say, but it's not really web standard. Like, it's only defining the JavaScript things, and they have a similar project to run feature tests to check which engine supports which language feature. Yeah, and one, I almost forgot. This is not for you, but if you know someone who often complains about incompatibilities, you can point them to this project called WebCompat, and it's actually doing the same thing, but under the hood, and it allows people to report inconsistencies, and then hopefully someone else is going to fix them for you. So if you know someone complaining about compatibility issues a lot, then yeah, you can point them there. Yeah, finally, I want to say that the web is a moving target, and it's going to move faster and faster. Like, the release cycles of the browsers have been changed to 4 weeks, and we have at least 3 different engines. Even Safari is increasing the release cycles, even though it doesn't tell you when it's going to happen. So it's moving faster and faster, and I like that. Like, it's nice to get updates that frequently, but it's also tricky from time to time. So a web platform test doesn't make the speed any slower, but it's just making the road a little less bumpy so that it's safer to drive. Yeah, thanks a lot.
Thank you, Christoph. Now, we do have time for a couple of questions. So who has a question for Christoph from the audience here? Yes, sir. Now, I'm going to bring my mic to you, and you can.
So from your experience, both contributing and lurking, how long would you say is the response time both for merging in PRs and also for browser vendors actually acting upon it?
Is there a specific reason for asking that? Because it's
no, just yeah. If I was to contribute a test, just wondering, does it make more sense to contribute it directly to the as a bug to the browser repo, or rather?
Yeah, actually the response time is faster if you, at least in my opinion, there's no scientific, well, maybe someone made a statistic on this, but I can only talk from my personal experience, and this is definitely faster if you do it directly on the browser bug tracker, because then someone feels responsible for it. Like, the disadvantage of having this common project is that sometimes no one really takes action because everyone thinks maybe someone else is doing it. So yeah, I actually looked this up for the preparation of for this talk, that my first PR took 13 months to get merged.
It's full honesty here at ComCon. Okay, thank you, Christoph.
But it's worth it, like, yeah.
Sure. Any further questions? Okay, in that case, let's thank Christoph with a ComCon round of applause.
Thank you.
And what that means is you might be free to go slightly early. Remember that dinner is at 6 o'clock tonight, so you've got some free time now. Lots of fun there. And we'll be back here tomorrow. There's a main address like there was this morning in here after breakfast, and then the sessions will split back into the 2 rooms again. So thank you very much for your participation. Give yourselves a big round of applause as we say goodbye.